All right, quality pros, let's talk about something we all deal with, fighting the same fires over and over again. Well, today, we're cracking open Section 10 of the ISO 10009 standard, all about corrective action. We're going to gear up with a powerful toolkit that's designed to stop problems right at their source and turn those annoying, recurring issues into permanent solutions.
So, here's what we've got on the workbench today. First, we're going to get the philosophy behind the whole toolkit. Then we'll look at the tools you need to really define the problem. After that, we'll grab our shovels and dig for those pesky root causes, map out some really complex systems, and figure out how to choose the right path forward. And finally, we'll take a quick peek at what else you can add to your arsenal. Let's get right into it.
Okay, first things first. Before we even pick up a tool, we need to get our heads in the right space. We need the right mindset. And that mindset is called root cause analysis, or RCA for short. It's really the philosophy that guides every single thing we're about to do.
You see, RCA is all about being a detective, not just a firefighter. We're not interested in just slapping a patch on a symptom so we can run to the next emergency. No way. We want to find out what started the fire in the first place and make absolutely sure it can never, ever happen again. It's about solving problems for good.
And this quote just nails it. You know, chasing symptoms, like a single product defect, is a game you'll never win. You'll fix it, and then you'll be back fixing it again next week. But if you find the fundamental cause, like, say, a machine that's slowly going out of calibration, well, you don't just fix one defect, you prevent thousands. That's the power we're talking about.
So before you can fix anything, you have to know exactly what you're up against. A vague, fuzzy problem statement is only going to lead to a vague, fuzzy solution. And that's where our very first tool comes into play. It's all about precision and clarity. I absolutely love this tool because it forces you to think not just about what the problem is, but also what it is not. You're basically building a fence around the issue. That moment you realize a defect only shows up on the night shift or only happens with material from one specific supplier, that's a massive clue. It lets you instantly eliminate a ton of other possibilities and points you exactly where you need to look.
And here's the real payoff, right? The little bit of time you invest up front using this tool saves you countless hours down the road. You stop chasing ghosts, you stop investigating dead ends. It's really the ultimate measure twice, cut once approach for problem solving.
All right, so our problem is crystal clear. Now, it's time to put on our investigator hat. Let's grab the tools that help us dig past the surface and unearth what's really going on underneath.
Now, this might just be the simplest tool in our entire kit, but don't let that fool you. It is incredibly powerful. It's all based on that simple curiosity we all had as kids. Just keep asking why until there are no more whys to ask.
Let's just walk through this one. So the car won't start. Why? Well, the battery's dead. Okay, but why is the battery dead? Because the alternator isn't working. And why is that? The alternator belt broke. Why? And there it is. The car missed its scheduled maintenance. See what happened there? The root cause wasn't a broken part. It was a broken process. And that is what we really need to fix.
But, what happens when the problem is a bit more complicated than just a broken belt? For that, we've got the fishbone diagram. This is your absolute go-to for a structured team brainstorm. It makes sure you're considering all the possible things that could be contributing.
Just look at this simple example, a late pizza. By using these standard categories, like man, machine, method, and material, a team can quickly get all their ideas organized. Was it a new driver? Is the oven taking too long? Is our routing software just not working well? This whole thing prevents that tunnel vision and really helps you see the entire picture.
Okay, let's build on that idea. The fishbone diagram is fantastic for brainstorming different categories of causes. But what happens when the problem isn't just one thing, but it's about how different failures interact with each other inside a complex system? For that, we need an even more powerful mapping tool. Let me introduce you to the fault tree analysis, or FTA. This is what you pull out when you need to understand how multiple things can go wrong, and that includes human error, to lead to one single big failure. You actually start with the failure at the top, and then you work your way backward, logically connecting all the potential pathways that could have led to it.
This no hot water example is perfect for explaining it. So you could have no hot water if the boiler fails, or if the power fails. That OR gate means either one of those is enough to cause the problem. But now look under boiler failure. For that specific failure to happen, the pilot light has to be out and the gas valve has to be closed. That AND gate shows you that you need multiple conditions to be true at the exact same time.
So what the FTA does, better than almost anything else, is visualize those hidden dependencies and risks in a system. But there is a catch. To use it right, you have to know your system inside and out. I mean, you need the blueprints, the process flows, the real-world knowledge of how every single piece connects.
So we've defined the problem, and we've found the cause. Great. Now what? Well, the next step is actually doing something about it. And for that, we need a tool that makes sure everyone takes the right action every single time.
A decision tree is basically a roadmap for action. It just takes all the guesswork out of how to respond when something unexpected happens. By creating a clear, repeatable process, you're empowering every single person on your team to make consistent, correct decisions.
And look how simple and effective this is. An unplanned event happens. First question, is there a standard procedure for this? If the answer is yes, you follow it. If the answer is no, you escalate it. This super basic logic takes all the panic and guesswork out of the situation. It means even your newest team member can respond correctly every time.
The main benefit here really is standardization and empowerment. It just makes your processes so much more robust and less dependent on any one person's tribal knowledge. The key is to just start by making these for your most common issues, and that's where you'll get the biggest bang for your buck.
Okay, so we've covered the core tools for corrective action right out of ISO 1009. But, a true craftsperson always knows their toolkit can be expanded. There are always more specialized instruments you can add.
Think of these as your next level of specialization. For instance, an 8D chart is a super disciplined, team-based approach for really complex product problems. It's actually a global standard in a lot of industries. On the other hand, you've got something like Lewin's force field analysis, which is just fantastic for managing change. It helps you see what forces are pushing for and against a solution you want to implement. Every tool has its place as you build out your problem-solving arsenal.
And there you have it. From defining a problem with an is/is-not analysis, all the way to mapping complex system failures with an FTA, you are now equipped with the fundamental tools from ISO 1009. And remember, this isn't just about checking a box for compliance. It's about building a culture of real, sustainable, continuous improvement.
So I'll leave you with this one thought. You're holding the toolbox. You've seen what each of these tools can do. The only question left is, which problem are you going to solve first?